Ever wondered why science is often called magic? Let's explore this together. Picture this. You're a child, watching the world around you. Every new sight, sound and sensation is a mystery waiting to be solved. A firefly flickers in the night, a rainbow arches across the sky after a storm, and the moon seems to follow you wherever you go. It all feels like magic. But then, you grow up. You learn about bioluminescence, light refraction, and the moon's orbit. Suddenly the magic is gone, replaced by scientific explanations, but is it really gone? Or has it simply transformed from the magic of the unknown to the magic of understanding? That's the beauty of science. It takes the seemingly unexplainable phenomena around us and gives us the tools to understand them. It's the magic wand that turns the unknown into the known, the fear into curiosity, the confusion into clarity. Science isn't about robbing the world of its magic, it's about enhancing it. It's about turning every question mark into an exclamation point, every why into a wow. It's about making the ordinary extraordinary and the extraordinary understandable. Imagine science as a book. Each page is a new discovery, a new piece of the puzzle. As we turn the pages, we uncover the secrets of the universe, one experiment at a time. Each revelation, each aha moment, is a spark of magic, a mini miracle in itself. And the best part? You don't have to be a scientist in a white lab coat to experience this magic. All you need is curiosity, a dash of creativity, and a thirst for knowledge. So whether you're at school, at home, or anywhere in between, you can create your own scientific wonders. So let's dust off our magic wands, otherwise known as our scientific tools, and dive into the realm of scientific discovery. Let's celebrate the magic of science, not as a destroyer of wonder, but as its creator. Let's embrace the magic that lies within each question, each experiment, each discovery. Are you ready to dive into the world of science and unravel some of its magic? Have you ever seen a lava lamp? Ever wondered how it works? Well, you're in luck because today we're going to make a homemade lava lamp, and it's easier than you might think. All you need are a few household items: oil, water, food coloring, and effervescent tablets. Let's start with the concept of density. Density is a measure of how much stuff, or mass, is packed into a certain amount of space, or volume. Oil and water are a perfect example of this. Oil is less dense than water, so when you pour oil into water, it floats to the top. Now let's bring in the food coloring. Food coloring is denser than both oil and water, so when you drop it into the mixture, it sinks through the oil and mixes with the water beneath. This is where our lava lamp starts to get its color, but we're not done yet. The real magic happens when we introduce the effervescent tablets. These tablets contain substances that react when they come into contact with water. They start to dissolve, creating gas bubbles in the process. So what happens when you drop one of these tablets into our homemade lava lamp? The tablet sinks to the bottom, and as it dissolves, it creates gas bubbles that rise to the top. These bubbles drag some colored water along with them, creating blobs that look like lava. Once the gas bubbles reach the surface, they pop and release the gas, causing the colored water blobs to sink back down. This process keeps repeating, creating the mesmerizing effect you see in a lava lamp. And there you have it. By understanding the principles of density and chemical reactions, we've created a homemade lava lamp. It's fascinating to see how simple household items can illustrate such profound scientific concepts. So the next time you gaze at a lava lamp, you'll know the science behind the spectacle. It's not just a cool decoration, it's a demonstration of science in action. There you have it, a homemade lava lamp. Science is indeed magical, isn't it? Scene script. Ever wanted to send a secret message no one else can read? Let's make some invisible ink. Imagine you're a secret agent needing to communicate covertly with your team, or perhaps you're just looking for a fun, science-based activity to do at home. Either way, invisible ink can be an intriguing and educational solution. Now, how do we create this magic potion? The process is surprisingly simple, and you'll need just a few common household items. Grab a lemon, a cotton swab or paintbrush, a piece of paper, and a heat source like a light bulb or a hairdryer. First, squeeze the juice from the lemon into a bowl. This citrusy liquid will be your invisible ink. Dip your cotton swab or paintbrush into the lemon juice and use it to write a message on the paper. Once the juice dries, your message will be clear to the naked eye. But how do you reveal the hidden words? That's where the heat source comes in. By gently heating the paper, you'll make the secret message visible. Be careful not to burn the paper, though. Now, let's dive into the science behind this. The reason this works is due to a process known as oxidation. When the lemon juice, which is acidic, is heated, it speeds up the oxidation process. This causes the lemon juice to darken and become visible. Essentially, you're speeding up the natural process that would occur over time. The beauty of this experiment is that it combines the intrigue of secret messages with the real-world application of scientific principles. As you can see, science is not just about complex formulas and lab experiments, it's in the everyday things we do and see. It's in the lemons we squeeze, the heat we feel, and yes, even in the secret messages we write. Now you can send secret messages that only those who know the trick can read. Isn't science fun? Do raisins dance? They do in our next experiment. Welcome to the fourth adventure in our series where we'll be diving into the fizzy world of dancing raisins. Yes, you heard it right. We're about to make raisins dance right in the comfort of your home with a simple yet fascinating scientific principle, buoyancy. Let's get started. For this fun-filled experiment, you'll need a clear glass, soda, and of course, a handful of raisins. The glass should be filled 3/4 full with soda, and then drop in a few raisins. Now watch closely. At first, the raisins sink to the bottom of the glass. That's because they are denser than the soda. However, magic is about to happen. As the raisins sit in the soda, they start to collect tiny gas bubbles. This is due to the carbonation in the soda, which is basically carbon dioxide gas dissolved under pressure. As these gas bubbles cling to the rough surface of the raisins, something interesting happens. The raisins become less dense and start to rise to the top. They're buoyant. This is where the dance begins. Once they reach the surface, the gas bubbles pop and the raisins, now denser again, sink back down. This up and down movement of the raisins, driven by the formation and release of gas bubbles, creates the illusion of a dance. This is a perfect example of how buoyancy works. When an object is less dense than the fluid it's in, it floats. When it's denser, it sinks. The raisins are constantly switching between these two states, creating our dancing effect. Isn't it fascinating how a simple glass of soda and a few raisins can demonstrate such complex scientific principles? It's a fun experiment, and even more than that, it's a learning experience. It's a reminder of how science is not just confined to textbooks and laboratories. It's all around us in our daily lives, making raisins dance in a glass of soda. Who knew raisins could dance? With science, anything is possible. From homemade lava lamps to dancing raisins, we've seen science in action today. Each experiment showcased not just the fun side of science but also the fundamental principles that govern our world. Let's take a quick stroll back through our science journey. We began with the homemade lava lamp, a bubbling spectacle that was more than just a colorful display. It was a lesson in fluid dynamics, demonstrating how oil and water refuse to mix due to their different densities. Then we added fizzing tablets, which created gas bubbles that ascended and descended in the lamp, a perfect illustration of buoyancy in action. Next, we delved into the world of secret messages with invisible ink. This wasn't just a nod to the thrill of spy games, but an exploration of chemical reactions. We saw how the acidic lemon juice weakened the paper, and how heat sped up the oxidation process, making the message magically appear. Then we closed our experiments with the whimsical dancing raisins. It wasn't a choreographed performance, but a demonstration of how gas bubbles can influence the motion of objects. The raisins, initially sinking due to their higher density, were lifted by the carbon dioxide bubbles from the soda. Once these bubbles popped at the surface, the raisins sunk back down, creating a fun and rhythmic dance. Each experiment was a testament to the beauty of science, to the laws that quietly shape our everyday lives. And the best part, all of these adventures were conducted right at home, proving that you don't need a fancy lab to explore the wonders of science. But our journey doesn't end here. There's a whole world of scientific phenomena waiting to be discovered. So let's keep that spark of curiosity alive. Let's keep asking questions and seeking answers. Remember, the magic of science lies in our curiosity and willingness to explore. So keep asking questions and keep experimenting. Until next time, happy science adventures.